In this problem, we're trying to find the area under the curve f of x equals negative x plus 2 from negative 2 to 1. Now, technically, this one, we could find the area pretty easily using area of a trapezoid, because if we look at this, that's all we have. But just to get a little practice with these types of problems, we'll take a look at this one using rectangles. It's a little bit easier than the last one with a quadratic function, and it'll give us a little practice with the format. So, trying to find this area, and we're generalizing, and we're going to use that formula that we had at the bottom of the last page. We're going to do the limit as n approaches infinity of the sum from k equals 1 to n of delta x times f of x sub 1. I'm sorry, f of x sub k. So we need to know what delta x is first. Remember, that's going to be b minus a over n. So our a is the left endpoint. Our b is the right endpoint. So we're going from negative 2 to 1. So we've got 1 minus negative 2 over n. So 3 over n. That's our delta x. Remember, all that is our base. And the f of x sub k is our height. Right? This sum is just the sum of all the areas of those rectangles, base times height. So we've got our delta x. The x sub k, sometimes it helps to kind of work this out this way. You may not need to after a while, but we're starting off with negative 2 plus, since we're doing this, remember this is a right-hand endpoint. So negative 2 plus delta x is going to give us x sub 1. Negative 2 plus delta x, so negative 2 plus 3 over n. To find x sub 2, we're just going to have to add 2 of those delta x's. So negative 2 plus 2 times 3 over n. To find the third one, we add 3 of them. And for x sub k, we're taking negative 2 plus k times 3 over n. Or another way we can generalize this, x sub k is going to be a plus k times delta x. Right, so you don't necessarily have to set up this whole thing like this. It's just going to be a, our first value here, plus k times delta x. That's if it's a right-hand endpoint. All right. So now we have the things that we need to start to find the area of that circumscribed polygon, adding up all those rectangles. So rather than starting off and like kind of writing it out like we have been, we have our formula. It's going to be the sum from k equals 1 to n of delta x times f of x sub k. Right, that's going to be the sum of that polygon if we take all those rectangles together. So we're going from k equals 1 to n. Delta x, remember, we already determined was 3 over n. And then f of x sub k. That means we're taking x sub k right here and plugging it in to our actual function for x. So we have to take this and plug it in here. So we have 3 over n times negative, we get that negative out in front, negative 2 plus k times 3 over n plus 2. Right, so we just took this whole expression, what we have for x sub k, and put it in place of x into the equation opposite of x plus 2. So I think, well, yeah, I missed a parenthesis there. So we need to do a little simplifying. So here's where we keep going with some algebra, taking the sum from k equals 1 to n of 3 over n, and we're going to end up, if we distribute that negative to each of these, we're going to have positive 2 minus 3 over n k plus 2. All right, so these 2's we can combine, that's going to be 4, and we can distribute this 3 over n. So we have sum k equals 1 to n, and remember, these add up to 4, so if we take 4 times 3 over n, we're going to get 12 over n, minus 3 over n times 3 over nk, 9 over n squared times k. And we can break this up. Okay, we can separate it into two separate sums. Sum from k equals 1 to n of 12 over n, minus, remember the n is a constant, so it's 9 over n squared times the sum from k equals 1 to n of k. This is where all those different formulas come in. If we take the sum of a constant, all it is the constant times the number of terms, so times n. Minus, here our constant is out in front, times the sum of k. This is the one where it's going to be n times n plus 1 all over 2. So the n's cancel out. Over here, this n cancels out with one of these. So we're left with 12 minus, we have the 9 times n plus 1 on top, so I'm going to distribute that. 9n plus 9 all over, on the bottom we have 2n. So remember, this is where we can split things up. This is like 12 minus 9n over 2n. Distribute that minus. So we have minus 9 over 2n. Here, n's cancel out. So we have 12 minus 9 halves minus 9 over 2n. So if we do 12 minus 9 halves, we just end up getting 15 halves minus 9 over 2n. So this would give us the sum of any circumscribed polygon depending on how many rectangles we choose. So if we choose 100, we could put 100 in for n. But the trick was, if we want to find the exact value, exact area, all we have to do is take the limit as n approaches infinity of 15 halves minus 9 over 2n. So the limit of a constant is just the constant. Limit as n approaches infinity of a number divided by n, that's going to be 0. So the actual area for this one is 7.5. All right, your homework for tonight is to go ahead and do these 3 problems, but ignore the directions in the book. Find the exact area using the right-hand endpoint. So that's what we were doing today. All right, and you have the answers right here so you can check, because the answers in the back of the book are going to be different. But you're finding these using the right-hand endpoints.